you need to do is, do you see the little shiny portion? I'll pass this one around, but you'll be able to see a little shiny portion. What makes that so shiny? Shiny. That's what we would say. Shiny, Ghana? Oh, it's shiny. Very shiny. Yeah.
Harder surface rubbing on it.
What's rubbing on it?
It's not sleeve.
Come follow me, I'll be your guide.
Valve guide.
Valve guide, okay, good. All right, so guide is right here. All right, so the valve guide is sitting there rubbing. Is that probably the biggest portion of the valve guide? It is, good. All right, so what you're going to do is you're going to go measure the valve guide right here on top, where it's the widest, and then you're going to measure this. And you have to sit down and do math. Oh. And the maximum clearance between this and this is listed in some of the older Continental manuals. It'll say 3 thousandths. What if I have less than 3 thousandths? That's a good. What if I have more than 3 thousandths? That's bad. All right, makes sense now? I will tell you, aviation, we have way more tolerance than your car engine. You would not get 5 thousandths on a car engine. Well, you will, but not for the good. Okay? But in aviation, you could see up to 4 or 5 thousandths. I know, that's crazy. It is crazy. All right? Good. So if you're seeing that and you're saying, dude, give me a measurement this way. That's totally okay. It may say 3 thousandths. Well, you have to look at that and say, well, logically, it's not 3 thousandths. Now, why wouldn't I want to measure right in here or way up here? Say it again. Yeah, it doesn't wear there. So you want to take the portion of this one that wears and the valve guide that wears the most and make sure that that's your tightest tolerance. Okay? If any of those are out, throw it out or change it. Make sense? All right. Back to plank. Okay? Your book, I don't know if the new book, my book is wrong. Your book may be right, so check it real quick. The new book may be right. L should be put in feet. L should be put in feet. Okay? The old book did not say that. It said put in inches. The new book, I'm not sure. But L should be converted into feet. So 6 inches is what? 0.5. Okay, if you're not sure what it should be, put it over 12 and divide it. Okay? All right? So in this case, pressure is going to be given. Okay? Zachary, can you talk me through it, buddy? So we got 125 times what?
0.416 feet times 12.57.
Where did this come from? Wait a second. No. Where did that come from?
4 divided by 2 squared.
Because the bore. What is the bore? Carter Marsh, what's a bore?
It's the surface area of the cylinder.
Okay, yeah, surface area, meaning the, yeah, diameter. Good. Beautiful. So then you take that, you square it. So 2 squared, 4 times this is 12.566, I think. 12.566 is right. Okay, 67, whatever, 67. So funny. All right. And then revolutions per minute.
You have to divide that by 2.
Divided by 2. Why? Why are we not getting this? Hey, Thomas, camshaft turns how many times in relation to crankshaft?
Twice. Camshaft turns twice, so 1 revolution of the crankshaft, right?
If you flip those, you'd have it right.
Crankshaft turns once for every 2 revolutions. Crankshaft turns twice for 1 revolution of the camshaft.
Yes! Okay.
I think I got that backwards.
Okay, beautiful. All right. So, here we go. You want to do it or you want me to do it?
We want you to do it.
Crank. Piston goes down. Intake goes up. Oh, that's one revolution. What's that second stroke called? You said it. It's not power stroke.
Impression.
Mega noita. Okay. No, not never. Okay. So, and then the third one is power stroke. Oh, we're at a, and then exhaust stroke. It went up twice. It came down twice. That's the crankshaft. Okay. Your intake valve opens how many times during the process of combustion? On a single cylinder, how many times does it open? Once. How many times does the exhaust valve open during a complete cycle? Once. Yes. And what opens the valves? The camshaft. So that opens therefore one time. Good. So we're going to have the revolutions of the power stroke. So if you're running at, Thomas is in a hurry, and he's going to drive to smack, or maybe you're like some of you that show up a little late, and you're in a hurry. So you're driving at 8,000 RPMs. So you're cranking it out to 8,000 RPMs. How many power strokes do I have at 8,000 RPMs? 4. How many at 6,000? 3. Good. So your power strokes are half the amount of revolutions per minute. Why? Because we're looking at a 4-stroke. If I was cranking out my dirt bike, my dirt bike is a 2-stroker. How many power strokes at 10,000 RPMs? 10,000 power strokes. That's insane. Okay? It's cranking it out. A little weed eater, okay? Wow, wow, wow. Okay? So, we're talking about a 4-stroke engine. We're at 1,500 power strokes. Okay? Unless you're in a hurry, then we're going to go up from there. Okay? So we're going to go over to 1,500. Okay? And then what is K? Killanders. Good. Killanders. Okay, thank you from the metric man back there. Okay? Okay? Okay. How many killanders do I have? I don't know. All right. So how do I know how many cylinders I have? Look at it. 1, 2, 3, 4, 5, 6. Ah, very good. Very, very good. All right. Then we're going to put this over what?
33,000.
Why 33,000? That's what one honking horse can do. That's right.
Ryan, serious question. Do you happen to know when they were measuring how much the horse could do, the 33-pound weight, he
33
he or
pounds.
she, could have been either one, the horse, either the horse. How did they trot 1,000 linear feet? Did they go in a circle?
Oh, I'm sorry, guys. The 33-pound weight was for my mind to understand. Because I didn't want to talk about sacks of barley because I'm not an advocate for,
Okay.
brew, whatever.
So it could have been like 100 feet.
Melissa's coffee.
Could have been 100 feet.
I'm on your side.
I was picturing a horse lifting a 33-pound weight 1,000 feet. That's pretty incredible.
In 1 minute.
In 1 minute.
Giddy up. Okay, all right. All right, can somebody do the math for me? I done it, but can you do the math for me?
178.265454.
What is that, big boss?
No,
What is it?
IHP
Indicated
indicated horsepower.
horsepower. All right, 178 horsepower. I know what you're thinking. Man, that's a Chevy Cruze. It probably is, okay? Or a Toyota, Toyota Sienna or a Honda Odyssey, okay? Whoop-de stinking do. All right? That's what's actually, created within the cylinders. Just just means you're not going very far, very fast. Because what's horsepower? What is horsepower? Come on, students. The rate at which work is accomplished. Don't make it very difficult. Just think of yourself hauling down the interstate at 80 miles an hour. You're getting it done quick. Is that simple enough? Now, what is torque? What it takes to get me to the 80 miles an hour. The amount of pickup to get that engine set in motion. Okay? Everybody's okay now. All right. Do you need to know what plank is? No. What is plank? It is the calculation that we do to figure out indicated horsepower. Everybody good? Good deal. Okay, go ahead. Shane just stepped out on the phone.
Okay, I just need you for 5 minutes once you fix your ethic.
Oh, tonight. Okay. All right. I would like to talk through valves. Is there any questions on horsepower, indicated horsepower so far? All right, let's talk about valves. What is the purpose of valves? Sorry, I did not give you an opportunity. Are you guys good? Okay. Bring air in and bring air out. Push air out. Okay. Add to that a little bit. We're going to take it from elementary now. We're going to middle school. Okay, proper timing. And anybody remember the word VE? What is VE? Oh, you said it. What is it? Oh, maybe not. VE. Volume. What? Volumetric efficiency. Oh, I know we heard this. Was that on Monday? Maybe Monday. All right. What was volumetric efficiency? What is volumetric efficiency? Ability. Go ahead, Marcy. Come on, Joe, add to it then. Volume is ability of a cylinder to take in, suck, squeeze, bang, and then push it back out. Okay? If a cylinder cannot do that, for example, too weak of a spring. You guys ever measured spring tension? With a valve spring tension? Okay. What was the purpose of that besides busy work? It was not busy work. If a spring is not strong enough, it will not open the valve. There's a purpose in it. If it's too low, okay, the valve's going to open too much. If it's too tight, the valve's not going to open enough. What happens if the gap is too much between the push rod and the rocker arm? If the gap is too much, yes, it won't open enough. What if it's too tight? No. It won't close. If it's too tight, the valve may not close or it may open too long. We ever talk about scavenging? Valve overlap? Okay, you're going to rig a 235. I did not rig one in school. And so as a result of that, this is a, cause and effect? It caused me frustration, therefore the effect was I'm fixing that. Okay, so 235, 290s, I want you to be able to go out to an engine and not act like a buffoon. Physically go out to one, turn it through like you're doing timing, open the valve. Oh, there's the compression stroke. And you have to do all, like this student that I just did the P51 Mustang, had to do all 12 cylinders on compression stroke. Pull it up, compression stroke. Okay, check the valve clearance on compression stroke for each cylinder. He had to physically count 1 through 12. Okay? And the goal was so that the valves did not open too much. The valves open too much, it's It's gonna be open too long. It could, if it's an interference engine, hit the piston. Okay? All right? It doesn't change much, or it doesn't very much. Ask my sons. One of them decided to rig a valve for me while I was not there one time. Got home, rode it, hit the top of the piston, made a nice hole. Okay? Holy piston. All right, everybody good? Any other questions, comments? Hey, you're really real now. Okay. Let's take a look at this. I want you to be able to see one of these cylinders. This is an IO360. This is not your friend. This is your foe. But it's a little high maintenance, okay? So it may be your bread and butter if you're working on Sky Masters or Sky Disasters. They were also on some 172 XPs, some 175s that did not have the GO300s or the IO360s or O360s. This is a Continental 360. Anybody confused yet? Why did Lycoming and Continental both do 360s? Do you know what the difference between a Lycoming and a Continental 360 is? 2 more cylinders. Continental 360 has 6 cylinders, but they're little babies. Look at it. Look at that. So little. Okay? Versus a Lycoming has a 5.1-inch bore. So this one's like right at 4. Okay? So this is a Continental IO360. It is IO360. Sorry, I had to do a double take. All right, this is going to be a little bit of your nemesis, so I want to teach you through it, okay? And if it doesn't work, we'll get the man up here, okay? Whoa, oh, whoa, all right. If I turn the light off, are you going to go out on me, or are you guys going to hang in here? You going to hang in? Should I put the thing down? Whatever. Okay. Whoa, that's not helpful. Oh, that's horrid. Okay, great. I'm trying to get you to see this. Can you see this little line? Can you see the line on the end of the valve? Can you see it?
Yes. Yes.
Don't move, Ryan. Hold what you got. Can you see it now? Right there. What makes a line along the end of the valve stem? Rocker. What about the rocker? Yes. If I see this, let's do this. Let's ask Israel. Israel's lively this morning. Let's ask Israel. Israel, if I see a flat spot like this on a lifter, what does that tell me as a detective? I mean, aka mechanic. But what does that tell me as a detective? On the face of a lifter, if I have a flat spot on a lifter, or tappet, whatever you want to call it, what does that tell me about the tappet? Not spinning. Valves, just as lifters, are supposed to sit inside their little cubby hole or bosses and rotate with oil pressure. Valves also are supposed to be rotating. They are. Did you know valves rotate? Not a lot. Just a wee bit. Do you think this valve's been rotating? No. If you remove your rocker cover, why do they call it rocker cover? Because it covers the rockers. Okay. If you remove the rocker cover, this one has 2 different rocker covers, and you see this below it, and you see a flat spot on the rocker, what do you know? The valve has ceased to do its job. It's not rotating. Okay? What's the problem, Jedediah? If a valve doesn't rotate within its seat?
First think of corrosions or lack of oil.
lack of oil or corrosion, what's going to happen with the valve to the seat?
Valve to the seat.
Yeah, let me put it this way. If somebody goes home and lays on the couch all the time, what do you call them? A couch potato. If this valve decides to sit in the same spot all the time, it becomes a stuck valve in that spot, okay? It gets in a groove and will not rotate anymore. It actually begins to wear into the seat. Becomes a potato in that spot. Now you'll never forget it. But. So what needs to happen right here? What would need to happen? Okay, so then we're going to reface by grinding the end of this valve. And you can take this down a little bit. Back to what Grant was talking about. This is all leading back to what Grant said. It's his fault, not mine. So Grant was talking about measurements. In the Continental Manual, it gives you a height of the valve. It's because over time, valves actually stretch. They're getting pulled on with keepers. They begin to stretch. If they get too long, we can actually grind them just a little bit, or in this case, worn out. For either reason, they'll have to be ground. Okay? They also give you a thickness. If it gets too thin, it throws away. That's why they give you a differential measurement. If it gets too thin, the valve's too thin, it also gets thrown away. Too stretchy, stretches out, or too worn. For either reason, the valves stretch. Everybody okay? You kind of got what I'm looking at? Now, let me show you a valve that's rotating, because you said, now I see a bad one. There's a good one. Do you see the circle on it? How it has a little circle around there? Inside on the valve stem? That's a nice little rotation, isn't it? Isn't that cool? There's a bad one. See the bad one now? Can you see what I see? Any questions on what we're looking for when we open up a valve? Hey, if you can be here on Tuesday, that'd be a great blessing. Because my goal is, as a mechanic, to get you into a cylinder in 5 minutes. Tell you, somebody pulls in their aircraft into your hangar and they said, man, I have something really rough with my engine. Okay? I'm not going to go attack timing right off the bat. Okay? I'm not assuming that the last mechanic was a buffoon and just totally messed up the timing. Typically, if it flew it out of there, the timing was probably going to be pretty good. Okay? If they come in on a routine flight and said, man, I'm having a miss, I'm not going to go and attack timing, correct? That just doesn't make any sense. If you're driving your car all the time and all of a sudden, man, something feels a little off, you wouldn't say, oh man, I bet the gears all jumped off. You wouldn't say that. You would say, man, I either have a fuel problem or a spark problem, right? Kind of got what I'm saying? All right, so I want to teach you, we're going to walk through, I call it the 5-minute cylinder inspection, where you're going to get in there and you're going to say, what am I looking for here? You're going to look through a cylinder, single cylinder, 5 minutes. Single cylinder, 5 minutes, single cylinder, but you're going to only do one, but we're going to do it on the mock aircraft, like you're trying to figure out what's going on over there. Okay? Does it suck, squeeze, bang, blow? You're going to be able to find that out pretty quick. We'll do compression checks. And I'll show you bad compression checks, and I'll show you good compression checks. How to die doing them, and how to live doing them. Okay? Nobody's going to die doing them. Okay? But I will show you, when you take your hand off the propeller, just how violent an aircraft can be. Okay? I am going to let one spin just to give you a respect for what we're doing. Okay? All right. The other nemesis on this one, real quick off the bat, what do you notice different about this cylinder? You have the intake is on top and the exhaust on the bottom. Do you know they do this with twin turbos? They didn't have a place for the intake, so they put the intake on the Sears twin turbos on top, because down here is the spinning things on each side with the exhaust, called turbochargers. So twin turbo 550s and some of the Bonanza B36s, oh yeah, they're B36s. Some of those did the intakes on top, okay? So don't be alarmed. 360 was just one of the first ones to do the intake on top, okay? So some of the 550s did them on top as well. All right, so this one, you'll have to use a rod. It doesn't come with it, but you can get a rod like this. I usually use aluminum, just aluminum plate across here. It even says 360 on it, just for you. Okay, there it is. So nice. Just a piece of aluminum. Shove it on there. It doesn't have to be super tight because the rockers connect slightly differently on this style. Okay. Then you take this bad boy, you go under here just like you did on the other ones, and you're going to break it loose. Okay. And then you'll pull them out like this. Please, please do not dent. If you get off center, it will dent when they're recessed valve springs like this. You could dent the housing. It's very thin. Okay. Everybody okay? Any questions with that? And then you pop the keepers out. Everybody was safe yesterday. I felt like we did a really good job. Some of them were pretty stuck. I get that. Some of them you have to fight. Okay. If you're wondering why, wow, this is so easy, just be thankful because some of your classmates didn't have it so easy. Some of them had it pretty difficult. All right. Any questions? Everybody good on what we're doing so far with our valves? All right. I'm trying to get you out of here, so I need you to hang on, okay? All right. Let's look at these two valves real quick. These are two valves that I have for you. Okay, so I fill the cylinder full of mineral spirits, and I hold it upside down, and it leaks just a little bit. Bummer. Okay, so then I want to reface the valve. This has been a valve that's been refaced. What do you notice? It's super shiny and pretty. It's shiny, okay? But it also has a little edge here. Okay, if I don't have the edge and it gets to a razor thin, see how that one's got an edge to it? See the little black edge on it? If the silver comes all the way to the end, what do I know about that valve? It is too worn out, okay? It needs to go away. This one as well has an edge distance. Once we cut a new face, which does not happen often, okay? It doesn't happen often. But sometimes we have to cut a new face if you have the machine. Say Shane buys a set of cylinders for a customer. Customer says, I want all 6 new cylinders. One thing is, that customer has a lot of money. Okay, so they want to drop 12 grand on a set of cylinders. When Shane gets those cylinders, they're going to have, if he buys Superior Air Parts cylinders, they're going to have brand spanking new valves in the cylinder. They're going to be shiny. They're not going to have any black on it. It's going to look super shiny. Okay? Before he just sends it, what he's going to do is what we call lapping the valve. Okay? Or if you have a valve that is leaking a little bit, we're going to have something we call lapping a valve. So you're going to take the valve. There's my valve. That's actually a pretty decent valve. It even says intake. It says the Superior Air Parts. This is not a Continental. This is an aftermarket. FAA, PMA approved, if you want me to put it generally, okay? You're going to take some toothpaste here called lapping compound. By the way, all of my students who have gone to work for United, did you know their very first day they get lapping compound on the job? Did you know that? Valve grinding compound? Now, last I checked, turbines didn't have any valves. They used them for their screwdrivers. They put them on the end of their screwdriver so that they can grip the screws so they don't strip them out. Just a little tidbit, just it's free, whatever. Okay? So, you take a little toothpaste called valve lapping compound. Now, this is common. Grinding it is not common. I will show you in groups of 5 or 6 today how to grind, but that's not common. Okay, everybody good? So then we're going to take a valve gonna say, you know what, it didn't seal. When we filled it with mineral spirits, it did not seal. I'm not happy. So this one's nice and shiny. You're gonna take a little toothpaste here, and you're gonna put just a little bit on it, just along the edge here. This is water-based. I had oil-based paste, and it's way better, way faster than this water-based. But today, we're using water-based. It's eco-friendly. Okay, I'll show you before I put it in there. Okay, this is what it looks like on there. Okay, so here's the same valve. Do you see how I have a thin coating on there? And it's got a grit to it. Okay, do you see the grit on it versus the way that one looks? See the difference? All right, so now we're going to take this and we're going to shove it in our exhaust side. Oh, without touching it, hopefully. You don't want to rub that all over the cylinder. It's kind of a bummer. Okay, then we have our fishing tool here. Okay, so this rotates back and forth like this, and then every, I don't know, I guess you can count it, it's like every 8 clicks, it rotates it 40 degrees. And then 40 degrees, and 40 degrees. So it's actually rotating the valve in there as it's hammering. So it's but you just do it fast, because it sounds cooler when you do it fast. Okay. Try to get it nice and stuck on there. If it doesn't stick, you can use a little Vaseline. Well, you stinking valve. Come on. I didn't clean the top of this valve. Do you guys hear it getting quieter though? Hear how it's getting smoother? It's not as grindy. I've done this with a lot of engines, so do it by hand if you don't have the tool. This one sticks super good to a clean one, like this one. It will stick to it, and then you stick it in there like this. Come on. There we go. Okay. So once you do it, you got to do it quite a bit, and then keep rotating it every 40 degrees or so, 45 degrees. Rotate. No, you can't use a drill on the end of the stem, Jimmy. Okay, I have had to use a fluid hose on the end down here and then put a clamp on it, and you can rotate it back and forth like that. Okay, I like to put a little pressure because our valves are so big compared to like a car. Back here. You hear how smooth it's getting? All right, let me see if I can show you what it looks like now.
Are you rotating it just like that one, like you spin a little bit and rotate it a little bit?
Oh yeah, yep, just the same thing. You want to do that even if you're doing a lawnmower. You have to do valves on a lawnmower. Same thing. Okay, so let me see if I can show you, and this is super important. Okay. This one's not wearing correctly, which is what I kind of was hoping would happen. All right. So cleaned up, you're going to see dark. Wait, you can't see what I see. Sorry. Do you see darker and then lighter? So So let me see if I can do this. Here we go. So this is real shiny here, and then all of a sudden we're starting to get a shadow. Do you see where the shadow ends right here?
Yeah.
Here, let's see on this side. Here's a good one. So it's shiny right here, and then all of a sudden we got a shadow. The shadow is what I want to see, but I want to see it all the way around. Okay? All the way around. It should look like this one. When we're done, that lapping should go all the way perfectly all the way around and have an edge distance right here. So the valve's not going too deep. So once you start lapping and we get shiny spots or uneven shadow, like this right here. Do you see where it stops right here? I can pass this around to help you. Okay, you should have a shadow all the way around. But see, there's no shadow right here. Okay, so what does that tell me about the valve and the seat? Come on, what is logic here? It's not matching. Okay, so is that valve going to spin when it's back on the engine? No, it's got a low spot. Okay, it's not even touching right here. Is it actually going to seal? So what do? We lap it again. And if it still doesn't go, then you may have to go back to a grind. Okay, does that make sense? So lap it. Today we're going to grind them, and then we're going to lap them. And then you're going to test them to see if they leak. So once they're done, you got this little line that's pretty consistent. Two things I'm looking for on the consistency: the width of the shadow, as well as all the way around in the same spot. If I saw the shadow was all the way at the corner here, right here at the corner, if the shadow was all the way at the end of one and it's all the way around the rest, what do I know about the seat? If this shadow comes all the way to the end, but the rest of it looks even, what do I know about the valve seat? The seat could be worn the wrong direction. Okay? Now, I will encourage you, we're not going to pull valve seats out of cylinders. Okay? Problem is we don't have the tooling at SMAT to put one back in correctly. They're extremely difficult to get in straight, and you'll crack an aluminum cylinder head in a minute. Okay? Because normally they'll put a very, very tight seat in there. They heat the cylinder almost to, it's like 1800 degrees, and then freeze the seat and shove it in. Then they go back and grind it to the right size. Okay? But it better go in straight. Okay? We will pull valve guides just to show you how to do it. Any questions on valve lapping? This is valve lapping. Okay? I'll show you grinding in a minute. Yes, sir.
Are there limits to who can do that kind of stuff, like a certified repair station, or is it just, that's why you have the equipment?
And you have a P by your name. You don't even need an A. Well, you got the P. Yep.
But I just got my A.
Well, you can't do this. All right. Yes, sir.
When are you doing that? Is it just when it's not seating properly?
Yep. They do it very regularly over at the LLC. They have a cylinder comes in and it has a sticky valve. I'm going to show you how to beat on a valve. I'm dead serious. I'm not joking. We call it staking a valve. I don't know where the phrase stake came from, but it just means that you're going to put the piston all the way down to the bottom of the cylinder, and you're going to take the rocker off, and you're going to hit the valve. Because what does the valve do? The valve opens like this, nice and smooth. And so what you're going to do is you're going to have the valve seated, and if it has a little deposits on it, we're going to get the engine very, very hot, turn the engine off, open the rocker cover, pull the rocker off, get the piston, turn the prop until the piston's all the way down in the cylinder, and you're going to hit it. Wham! With a brass punch, and it's gonna open and close very fast and knock all the deposits off. Then you're gonna do another compression check. And if it's sealed, you just beat that valve into submission. Congratulations. It's called staking a valve, okay? A lot of A&P schools don't do it, but I teach it very widely, and I've seen amazing results, saving customers thousands of dollars by spending $150 to pay me to go and beat on a valve. It's relaxing, it's enjoyable, and it saves the cylinder. Okay? Yes, sir.
And then the deposits are just in the cylinder
No,
now?
they actually go into usually into the exhaust, because when you close it, I mean,
Oh.
fine, it may go into the, but
You're talking about lead deposits?
yeah, or oil deposits. Yeah, they'll usually, when they close, they'll usually break off into the exhaust pipe. You can hear it if you listen closely.
You said that the valve spins over time. Type of
It
oil
rotates. It rotates.
You said see the oil pressure. Where is the oil being contacted?
Well, the oil is right here, but you have oil that's going on your valve springs. Right here. Oh, I have a cylinder. Why don't we look at that? You have oil up in here. Okay, we don't want oil on this side, but we do have oil up here.
This is the rocker sealing that way.
Yes, or we have rocker shaft seals. Yep. Or valve guide seals. Valve guide seals. Valve stem seals. Valve stem seals. Yep. Any other questions, comments? All right, last thing before I kick you out of here. Everybody ready? All right, we're not going to ask. I have heard very different phrases on these. Okay. When your valves are out, you can do this with the valves in. When you're done with your lapping compound, take some mineral spirits or whatever and get all of that out of the cylinder. If lapping compound goes down in the valve guide, what's logically going to happen to the valve? It's going to grind in a matter of a few days. Right in here. Okay? So what do I need to do? I normally will get them super clean with mineral spirits, and if I cannot be sure that, I use these giant Q-tips to get in there and clean it out until it's spotless. Okay? All right. Once the valves are set to go, now we're going to do a crosshatch. Okay? I'm going to tell you the proper method to do crosshatching. Crosshatching, what is crosshatching? I've talked about it 3 times now. Okay, it's making X's, it's drawing pictures inside the cylinder. It is giving, crosshatch gives the piston rings something to grab onto, or actually push oil into, because we need an oil film. Why do we need an oil film on our cylinder wall? Lubrication, okay, and sealing. If there's oil a little bit, we don't want a lot, but a little bit of oil on the cylinder walls, it helps with retaining combustion at the top of the cylinder, correct? The rings are pushing up against it. We don't want a lot. That's why they call it an oil control ring. All right, let me close this before I drop it and make a mess like Kurt did with a soda earlier, okay? All right, so the key to a flex hone, okay, if you open your car cylinder, they're going to have the same thing. The key to a ball hone or flex hone, some states call this a dingleberry, whatever. I have to say I've not used that since I was about 16 years old. We just call it a flex ball hone, okay, or a ball hone, okay? This one will fit all of the 5 series or 470 as well, okay? Okay, the key to the flex hone is to go slow RPMs but fast in and out. I put a piece of cardboard at the bottom of the cylinder. Why do I put a piece of cardboard at the top of the cylinder? Top of the cylinder, not bottom. Top of the cylinder. No. to protect the top of the cylinder. What is it? Aluminum. You're using a steel rod and a steel barrel with an aluminum head. Please think logically. If you have your valves in there, you don't want to destroy them. Okay? So when a cylinder comes in, if you buy a brand new cylinder, it's common to already have a crosshatch in it. But if you use an old cylinder, but you've got to get new rings, now we've got to get the rings something to work into. And it's called putting a crosshatch in it. Okay? So we want slow RPMs. Oh, that's so nice. Okay? Nice and easy as you go in and out. You should use lubrication when you're putting the flex hone in there. What's the proper thing to do? Mineral spirits. Okay? Some people have used oil. Oil is a bad idea. Bad idea. We actually want it to cut, and mineral spirits is thin enough to allow us to make a crosshatch in there, but also wash that material out as we're cutting grooves into our cylinder. Okay? Does that make sense? On the mission field, I've used two other things. I've used diesel fuel, and I've used WD-40, just because I don't think I ever saw mineral spirits when I was in Africa, ever. So you could use one of those two things. WD-40, do not use avgas. You guys are laughing. I've seen it. Don't use avgas. You're using friction inside a cylinder. Okay? Good way to die. Okay? So these are actual stones that you're cutting into the cylinder wall, and it should be crosshatch. What happens if my lines are like this instead of like the 45? Crosshatch should be about 45 degrees, 40 to 45 degrees. But if my lines are like this, what do I know? I'm going, you said something close. It wasn't exactly right. No, you're going in and out too fast, but you're rotating it too slow if they're like this. If they're like this, then we're rotating it too fast, or we're going in and out too slow. There you go. So like this, you're going in and out too fast. So we want about a 45. So then you stop and you look at it and you say, yeah, that's about good. Okay? All right, you can look at it. I don't even know. Maybe I can show you. This is an aluminum one that was a donor. It gave up its life for us. It's because it had chrome on chrome. Okay, can you see forget the vertical lines, okay? Obviously this cylinder is trash anyway, but let's see if you can see my crosshatch. Can you see my crosshatch lines? Oh yeah, you can right there. By my thumb right here. You see the lines going like that? That's about a 45 there. Okay? This would be, 90 degrees, and then somewhere between 90 degrees, that's about a 45 there. Do you see the scratches? Okay, yes sir?
It was pretty difficult to get this nailed because what you're trying to do is every rotation you're either going in or out.
And you want to keep it moving till you get all the way out of the cylinder, correct?
Especially with a drill like that. Is there any better tool we could use?
Yes, I actually have a home drill that is air powered, but I don't have air in here. So I'll give you that one. It's very, very slow. It's made just for this. It's like a drill on steroids. It's huge. But it's got a lot of torque, and it's super slow, even if you pull the trigger all the way in. Yep.
How much mineral spirits do you use?
Quite a bit.
Dousing it?
Quite a bit, yep. I've seen machine shops, they use mineral spirits or they use cutting oil, okay? And we'll use the same cutting oil when we grind valves momentarily.
I've used a splash of ATF in the past.
Okay,
Is that
sure. I'm just telling you what, I think the book even says mineral spirits, so whatever. All right, Stoddard solvent. Okay. Everybody else good? I'm trying to let you go, yes?
Best place for this is in
No, yeah, well, you're gonna have to have, we have that little one over there, if you wanna use the little one to be able to, run the flex hone in there. So what you're going to do today, we're gonna remove your valves. If you put them back in, good, that's great, perfect. We're gonna grind valves. If your valves are good, we may grind some scraps, but the goal is, then you're gonna, after we grind them, you're gonna lap valves. And then we're going to seal them. If there begins to get a real long line, then you can go ahead and lap your valves while some are honing their cylinders, okay? So some will hone, some will lap, and some will grind. If your valves are super good, they're not worn at all, you can go ahead and lap them and I'll have you grind different valves. Okay, I have lots of donor valves, lots and lots of donor valves. Okay, but if your valves are pretty worn or you can't get them to seal, then we'll go ahead and we'll grind those valves as well. Okay? All right. What we'll do first is I will take all of you on the back row and I'll show you how to grind valves first. And then I'll say second group, that's everyone down the middle row. And third group, save the best for last. Then I'll call you guys, okay? All right.
How long do you typically?
Maybe 7 or 8 minutes, max. Because I'm just gonna show you how to grind it and then you can do it yourself, okay? All right, I'm not gonna, I'll be there and around, but if I sit there and watch every one of you grind a valve, I won't really, I'll get as much done as I did yesterday. Nothing. Okay. Any questions on honing? All right, we have one ball hone for the large bore and one ball hone for the small bore. So you can't all do it at the same time. So there's one tank, that means one person should be on. Okay? Everybody good? Go and enjoy. Hey, the reassembly and disassembly lab should be done and coincides with what we're doing, okay?